So we've just started talking about how energy flows through ecosystems, and we've been talking a lot about ecosystems, but this concept of energy might be kind of new to you. And so you might be wondering, what is energy? Because it's kind of hard to define energy. We can only sometimes see it, we can't really touch it. So we need to understand a little bit about what energy is. Basically, energy is what makes anything happen. It's what makes the sun glow. It's what makes cars move. Light and heat are forms of energy, and energy also can be stored in chemical bonds that make up living things. And that's the kind of energy we're mostly going to be focusing on. Living things use energy for a lot of different things. So, like the plants in this picture use energy to grow, they use energy to reproduce, and they generally use energy to stay happy and healthy and stay alive. And we know that living things get their energy from food. So food is just stuff that has energy stored in it. Like we talked about how energy is stored in chemical bonds. Water is not food because there's no energy stored in water that an organism can use to stay alive. When we talk about food, we're mostly talking about three things: sugars, fat, and proteins. And we will talk about these things a little bit more as we move forward in the semester, but that's what we're talking about when we talk about food. And so there are two ways really that a living thing can get energy from food. The first way is to make its own food. And so an organism that makes its own food is called an autotroph. Auto means self, like an automobile is self-moving, and troph means feeding. So autotroph literally means self-feeding. And examples of autotrophs would be plants, because they make their own food, as well as these lovely little guys who are what we call phytoplankton. Phytoplankton. So the other way that organisms can get energy is by eating other organisms. And an organism that eats other organisms, eats the bodies of living or dead things, is called a heterotroph. Hetero means different or other, and troph still means feeding. So heterotrophs eat other things. And examples of heterotrophs would be animals and fungi, like mushrooms. So as we have learned, we can connect all of the living things in an ecosystem through a food chain. So lots and lots of energy is going to come in through the sun, and that energy is going to be absorbed by producers, plants. And our producers, change my pen color here. Producers are called that, as we've talked about, because they're making their own food. And so then producers would be eaten by primary consumers, like this grasshopper. So the energy is flowing from the producer to the primary consumer. Another word for a primary consumer is an herbivore, which means a plant eater. And from a primary consumer, the energy would flow to a secondary consumer. And so secondary consumers, as well as the tertiary consumers. I'm not going to write out the word consumer again, but I will write out the word tertiary. Secondary and tertiary consumers are carnivores, which means that they are meat eaters. And so energy flows through a food chain like this, from producers to primary consumers to secondary consumers to tertiary consumers, and then any living thing, once it dies, can be consumed by decomposers. And so we'll draw the energy going to our decomposers, like this mushroom and this cockroach. When anything dies, because they're heterotrophs, they get their energy from other things as well, and so they will eat the bodies of the dead things. So as we know, real ecosystems are going to be a lot more complex than just a simple food chain, and so we use a food web to show all those relationships. And if you look at a food web, you can just follow the arrows from these berries to this green fly to this ladybird, also called a ladybug, to this bird called a titmouse, and along the food chain. And any way that you follow the arrows through a food web is going to be one food chain. But one of the weird things about food webs is that if you look at it, so we could look at this food chain, the plantain to the rabbit to the buzzard, that's 2 links, 1, 2. Here's another food chain, it has 2 links. Here's another food chain, has 1, 2, 3, 4 links. Here's another food chain, 1, 2, 3, 4, 5, 6. That's a lot of links. This one has 1, 2, 3, 4. So there seems to be a limit to how many links there can be in a food chain. So you might wonder, well, why can't energy just keep getting passed through the ecosystem forever? Why is there only so many links in a food chain? And in addition to that, you might wonder, well, when I look around an ecosystem, why are most of the organisms in this ecosystem producers? Why do I see so many plants and not that many consumers? So to answer these questions about why there are just so many producers in an ecosystem and why there can only be so many links in a food chain, we need to understand a little bit about how energy gets passed through any system. A big thing to understand about energy is that no transfer of energy is 100% efficient, meaning that some energy is going to get lost. So if we look at one example, when you put gasoline into a car, there's energy actually stored in the gasoline. And the purpose of putting gasoline into the car is that some of the energy will be released and make the car move. And in fact, most of that energy does go into making the car move. And you may have heard of having fuel-efficient cars. A fuel-efficient car means that it's using most of the energy from the gasoline to make the car move. But not all of that energy, in any case, will be used to make the car move. Some of it is going to be given off to the environment as heat. If you've ever been near a car that's running, you might know that cars get hot. That's why running engines get hot, because not all the energy is being turned from the gasoline into the motion of the car. And something very similar actually happens in ecosystems when energy is passed along a food web. When we look at an ecosystem, we know that the source of the energy is from the sun, and tremendous amounts of energy from the sun are hitting the earth every day. So I'm going to use these big yellow arrows to show you how much energy is coming from the sun. Producers, like the plants, use that energy, they absorb it, and they turn it into food for themselves through photosynthesis. Then they use up most of the energy doing things we talked about earlier, growing, reproducing, and generally staying alive. A lot of the energy that they absorb from the sun, actually 90% of it, gets lost to the environment as heat, kind of like what happened to the car, because they can't use every single bit of energy from the sun and turn it directly into keeping themselves alive. So some of it gets lost to the environment. So when our consumers come along, most of the energy that the producers captured from the sun has already been used up and it can't be passed on. So the consumers are only going to take a small portion of the sun's original energy. So we're going to give some energy to our primary consumers. But then they will use the energy to grow and reproduce and stay alive. And in the case of these little animals, they're going to be moving around, and that generates some heat. And so they lose some energy to the environment as heat. So this means that now there's even less energy available to be passed on to the secondary consumers. Just small amounts. And so there's not very many secondary consumers because there isn't a lot of energy available to support them. And there's hardly any energy at all for the tertiary consumers. And so there are very few tertiary consumers in an ecosystem because there just isn't a lot of energy available to be passed on to them. And they need energy to stay alive. So an ecosystem can only support a small number of tertiary consumers. Scientists often represent this idea with an energy pyramid, like the one that's pictured here. So remember how we said that energy is stored in food? The energy pyramid represents the amount of energy that's stored in each trophic level, each of the feeding levels. So we have the producers at the bottom, primary consumers, secondary consumers, and tertiary consumers. So again, our energy is coming from the sun, and the producers absorb loads and loads of energy, and they are absorbing it directly. So there's lots of producers storing lots of energy. But remember, most of that energy is going to be getting used up by the producers because they're trying to stay alive and they do what they need to do and they use up a lot of energy. So only a small amount, actually only 10%, can get passed on to the primary consumers. And so the ecosystem can only support a fewer number of primary consumers than producers. And once the primary consumers use up some of the energy, then only a very, very small amount is available to support secondary consumers. And as the secondary consumers are using up energy, then that means just a tiny amount of the original energy from the sun is available to support tertiary consumers. So we will continue to discuss these ideas as we move forward next week, but now you should have a better idea of how energy flows through an ecosystem. And you should understand now why there are so many green plants in Earth's ecosystems.